I'm going to take a shot here at a live view of something that we put together for the Manitoba flood. I think everyone can see that. So in the spring, I was in the U.S. on business, and I read in USA Today that the water was flooding out Fargo, North Dakota. And I know enough about my geography to know that Winnipeg is north of Fargo, and floods could be arriving pretty soon. So this is, so let me just continue the story. This is a flash application here that we built for them. But I called up our my staff in Winnipeg and said, do they need any help? And they said, oh, they're worried that the water's coming up so fast they're not ready. So we asked them if we could help them, and we put together this thing in 4 days where we pulled together data from all over the place where they could actually look at the extent of flooding in the past. So let me just turn some of this flooding extents on here. So let's turn the flood extents on. And we can actually see where the floods were in historical floods, 1950. Let's turn a few of these on and off. So you can see the flood extents here. And also, I don't know what the weather's like in Winnipeg. Yep, there's a little rain. So we gave them live radar. So this is actually live radar coming through. But we gave them a lot of other things, for instance, stream gauges. This is connecting directly to the Environment Canada. So all I have to do is click on that, go down here and say, I accept. And it'll give us the live stream gauge. So that's actually the water flowing in that stream gauge. We see the flows here from sort of midday of today. So this gave them a common operating picture of what was happening to water levels, so we can actually just go around and hover over these. Let me just close that off and look at some of the other things. So I won't show you all of these, but they were able to look at road closures. These are roads that were closed during the flood. So these are not, you can see the red ones. These were updated every day by connecting to the Manitoba Highways site and getting a list of closed roads. They were able to look at where the hospitals are. So they could quickly go into a hospital and see what the details of the hospitals were, where the phone numbers were, and whether they needed to do any kind of evacuation. They also put their landing zones up. Where can we land a helicopter in the flooded area, with details on what the helicopter said. We also, I won't show it here because it's not live anymore, but we also put up the MODIS satellite imagery. The satellite imagery was brought down live every night and fed into their system. Also, the flooding each day was calculated by CCRS. So that was the flooding on the 24th of April. And so CCRS interpreted that from the RadarSat satellite and set up a service that they could connect to. And if they were looking at, let me just go in here just a little bit. Let me zoom into around in the South Winnipeg area here. We'll get in a little bit closer. And there's, you can see the rain in that area. So it's kind of, so if I actually want to say, okay, I need to evacuate this area here, let's just go in and do a quick polygon around an area. And we'll see what happens here. So it's now calculated the population for that particular one, and then I can just go see the individual assessment and see what population is in each one of those for that particular age class. So this was used throughout the flood. The minister was briefed every day. In fact, the deputy minister started to actually use this application on a regular basis during the flood. So common operating picture has become a major part of the Geoweb. How do we connect to a real live situation during emergencies or even not emergencies? So let's move on to another topic. The theme of this conference, I think, is very apropos, cityscapes. How do we actually bring together GIS and CAD and BIM? That's the technical side of it. But what are we actually doing? Why are we bringing those together? The theme of our conference this year in San Diego was GIS designing our future. And what does that actually mean? What do we really mean by that? Well, our cities are a product of our human design. We design them. We are quite deliberate. It's not a geological event the way cities have emerged. They've emerged as for a specific purpose. and we're quite deliberate about what we build. But sometimes we don't do such a very good job. We see this in urban sprawl. Designers are focused on site-specific things, and they don't always see things holistically. That's landscape architects see the whole, but perhaps building architects only consider their building. And I think that's why you see sometimes such ugly buildings for their site. They may look good somewhere else. So how do these come together? Well, geography is about describing our world, how the physical, economic, and social geography of our world. Design is about seeing the future. And typically these have been done in completely different technologies. And we can transfer data back and forth, but how do we integrate the process of understanding and describing our world and at the same time seeing what it will look like in the future? And that's the purpose of this conference, is how do we pull this together? How are we able to do geo-design? Not site-specific design, but design in the context of greater geography. And it's certainly necessary that we actually do this. We see our human footprint, particularly as we move to cities. You can see the incredible growth of population as we move to cities here. You can see the radical change it has on the climate. I was at the opening a few months ago of the University of Waterloo's Center for Climate Change, study on climate change. And one of the speakers there was an expert in ice in the Arctic. And he talked a little bit about what's happened over the last 150 years. We're projecting out here 80 years in this little video. But in the last 150 years, we've had an additional 1.6 to 1.7 watts per square meter hitting the surface of the Earth. So bear with me for a moment. This is interesting. 1.6 watts is about the volt wattage of one of those little LED Christmas lights per square meter. So that's about 1 trillion Christmas tree lights if you spread it all over the entire world. And those Christmas tree lights represent about the energy represents about 600 times the world's current electric generation capacity. And that's what's hitting the world as a result of warming. We would expect that it would have actually increased the temperature about 1.7 degrees, but it didn't. It's about half that. The rest is in the oceans. And as a result, the oceans have expanded in the last century in the order of about 30 centimeters, so about 1 foot with 0.9 degrees. So there's some concern that if we don't design our world better and that we don't consciously aim at designing our cities to be far, far less energy intensive and switch to alternative forms of energy, capture that additional 1.6 trillion watts of energy hitting the Earth and use that instead of fossil fuels. So what we're really talking about is major. We're talking about taking our world as we have mapped it and understand it and described it, take a process which has previously not taken the past and the future into account as much as it should, and develop a plan where GIS and CAD tools will work together and that the creation of the design will fit. So how would we do this? Well, first of all, we need to describe geography, inventories of data. And we're pretty good at that. That's what we've done for a long time in GIS. How does it function? Process models. What are the changes that are taking place, like I just described? What do the warming temperatures do? How can we alter that geography? We can run capability or sustainability models. And then we can say, here are a number of scenarios. We may sketch those scenarios out. Then we'll evaluate those scenarios. What are the consequences of that change? Because today we don't really fully understand the consequences of change. In fact, unintended consequences happen all the time.